Welcome. Welcome to AP Calculus students. We have reached topic 7. Topic 7 is the miscellaneous, the potpourri, if you're a Jeopardy fan. This is where you get, I won't call them random questions, but questions that don't fit into the other topics. Topic 7 tests pretty much anything. I've tried to highlight the things that students have the most trouble with, but you are not guaranteed to have a miscellaneous question. You're not guaranteed to have any of the other topic questions. Again, this is just how we're reviewing for the AP exam. So, implicit differentiation, that should be one of the things you always think about when you differentiate. You always think about basic shortcuts, the product rule, the quotient rule, the chain rule, and implicit differentiation. We haven't talked about it yet in our review. I'd like to remind you that you want to be thinking about horizontal and vertical tangents. Equations of tangent lines can come in here. Extrema, both relative and absolute. I know we talked about this with graphical analysis and the motion questions, but they can come up here. Related rates, that's the area I'm going to focus on today. So we have here a non-calculator question from a retired AP exam. I want you to make sure that you put in some time to try it out here. As usual, you would approximately have 15 minutes to do this question. So if it's taking you way longer than 15 minutes, this is going to be something you want to go back to. But I'm going to assume that you pause the video and try the problem. And then I'll show my work and the scoring guidelines. Okay, let's begin with my work. Part A, find the average value of the radius of the funnel. In this case, the radius of the funnel is given as an equation. So to find an average value, I know that I need to integrate from 0 to 10, the function value of the radius, and then divide that by the difference between 10 and 0. So this particular question has some obnoxious numbers that you get from your calculations. Notice how most of the points are for the calculus. So just bear that in mind. If you're really sweating out these simplifications, don't sweat out the simplifications. Leave it unsimplified and hope that you're going to get full credit. It's better to do that than to sweat out, spend a lot of time simplifying, and get caught. So anyway, power functions, I decided to do 1/20th times 1/10 for 1/200th. Antiderivative of 3 and h squared power functions. Evaluate at 10. When I evaluate at 0, I get 0. And then my units of inches are on here. Okay. Part B, find the volume of the funnel. So volume is integration of area. Think about the area and volume topics we talked about. You're always interested in the area of the shape if it's by cross sections. You're always interested in the area of the circle or circles if it's revolution. Make sure that you are integrating area. So I determined that the area of this circle is pi r squared. So squaring the radius, multiplying by pi, integrating from 0 to 10. I decided to square 1/20th and multiply by pi. That's where the power of 400 comes from. I distributed this out using the distributive property. I wrote down my antiderivatives, evaluated at 10, all of these, evaluated at 0, got 0. And then I did a smidge of simplification, and I wrote square inches instead of cubic inches because I don't know, who knows. Part C, the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, The radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. I read that out loud specifically because those are the types of things you want to be thinking about when you're like, do I use related rates? I don't know. Do I use related rates? I don't know. I don't know. I don't know. Yes. So you're looking for this kind of phrasing. Now, it's not perfect, doesn't always end up that way, but it's probably going to be talking at the least about implicit differentiation. So for part C, for my process, I just kind of wrote out that the height was 3 inches. PRDT is negative because the radius is decreasing when water's draining out. So I thought about the equations that I have. I've got an area equation that I came up with. I've got the radius equation. I've got a volume that I could have taken the derivative of. And I settled on the radius equation because it talks about what is the rate of change of height. And I said that is dHdt. And if I differentiate the 3 plus h squared times 1/20th, I'm going to get a dHdt. Okay, so then I replaced h with 3, drdt with negative 1/5, did some algebra, and got inches per second. So, scoring guidelines. 1 point for an integral. So you need some version of this. Notice how this one is slightly different from mine, but it's still fine. Antiderivative, you need some version of this. And then answer, you need some version of this. If all you have is 109/60th inches, that is a bald answer. You get no puntos. You must have the integral point, and I'm pretty sure the antiderivative point to get the answer point. Although it's possible, I wouldn't say likely, it's possible if you don't have the antiderivative, but you somehow have a correct integral and answer, they may give you more partial credit. I wouldn't plan on that. These are antiderivatives. If you're playing on a high score, you got to get 100 times out of 100. Part B, also 3 points. 1 point for the integrand. Some version of this. Notice that that is slightly different from mine. Antiderivative, some version of this. I think that's pretty much exactly what I have. Answer, some version of this. That one is simplified more than mine, but nonetheless, it is fine. Now, it's unclear from the scoring guidelines, but I would say if you don't have inches, you just have 109/60th, you get no answer point. If you have some version of 2209 pi 40ths, but you don't have cubic inches, you don't get the answer point. So make sure you have your units. So derivative of the radius function, pretty much the same as mine. Notice how that is worth 2 points. If you do not use the chain rule to get your derivative, you are not getting any points here, not even for your answer. And then the inches per second, again, are required to get the answer point. Which brings us to the end of topic 7, which is the end of AB calculus. Topics 8, 9, and 10 are BC calculus topics only. Those only appear on the BC calculus exam. Thanks.